In today's notes, we're going to be talking about ellipses. Before we get started with example 1 of graphing this ellipse, let's take a look real quick at the first page. Up in the top here, it says that an ellipse is the locus of points in a plane such that the sum of the distances from two fixed points, called a foci, is constant. And then we have some different characteristics that we're looking at. We have our major axis. Our major axis is going to be the longer one in our ellipse, and it can either go horizontal or you'll see below that it could go vertical. The center of our ellipse is the midpoint of the major axis, which is right here. The minor axis is going to be the smaller length. In this case, this picture is vertical, but it could go horizontal as well. Our vertices are the two endpoints of the major axis. So we have a vertex here and a vertex here. And our co-vertices are going to be the endpoints of our minor axis. So a co-vertex here and up here. If we look at our two different equations, we can have an ellipse that is longer horizontally, or we can have an ellipse that's longer vertically. With our equations that we have up here that are in standard form, we have x minus h squared over a squared plus y minus k squared over b squared. And this part right here is what's really important. You might want to circle or star this point. A is always bigger than b. So the difference between this equation and this equation is that the bigger number in this equation is under the x, and the bigger number in this equation is under the y. And then we'll use some of this information as we continue on with example 1. So let's take a look back at example 1. And example 1 says, to graph the ellipse, x minus 3 squared divided by 36 plus y plus 1 squared divided by 9 equal to 1. In order to graph this, the first thing we want is the center. To find my center, we're going to go back to that first page. Or actually, before we even find the center, we want to know which equation we have. So if we take a look at our equation, we have our bigger number under the x. So let's keep that in mind as we look at our equations. So if the bigger number is underneath the x, that means we are talking about this equation right here. And this is the information that we want. Our center is going to be h comma k. The h is coming from inside the x, and the k is coming from inside the y. Since our original formula starts with these minuses, they're going to be the opposite as they come out for our center. So our center for this one, we're going to take 3 and negative 1. So our center is 3, negative 1. The next thing we need is we need our major axis and our minor axis. So we need to know what the length of the major axis is, and we need to know the length of our minor axis. So if we scroll back to the front and look at our equations, the major axis is a horizontal length, is 2a, and our minor axis is going to be vertical in this one, and the length is 2 times the b value. And recognize the a value is coming from here and the b value is coming from here. This a is being squared, so to find a, we're going to have to take the square root of another number underneath here, and to find b, we're taking the square root of the number that's under here. Going back to our equation that we're looking at, if we need the major axis, we're going to remember the major axis in this case is our horizontal axis. And then we need to know the length of a. So in here, we know that a squared is that 36, which tells us a is going to be the square root of that, which is 6. So our horizontal axis, the major axis, is going to be 2 times 6, or a total length of 12. Our minor axis is vertical in this problem. And our minor axis is coming from our smaller one. So we take the square root of that 9, which is 3. So it's going to be 2 times 3, or a total length of 6. Now, in order to graph this, we are going to start at our center, which is at 3, negative 1. So let's plot that center. And then our major axis is our horizontal axis. So our major axis is going to be here. And we want the total length from one end to the other end to be 12, which means we want 6 in one direction and 6 in the other direction. So we're going to grab our pen and we're going to count 6 to the right. And we're going to plot that point, and we're going to go 6 to the left. and plot that point. Then we're going to look at our minor axis. Our minor axis is a length of 6, meaning we want to go 3 up and 3 down. So we'll grab our pen again and make those markings. So 3 up would leave us there, and 3 down is over here. And then we can draw in our ellipse as best as we can. Remember, an ellipse is going to be curved. If you have any questions at this point, let me know. Otherwise, you can move on to example 2.